Welcome to the last video of Unit 3. It's been a long one, but we made it, so congrats. Okay, so we're going to talk about solving inequalities. Last time we talked about just graphing them and putting them on a number line, so we're just going to add a layer to that. Okay, so I can solve an inequality. Remember that these are the inequality symbols. So less than, greater than, less than or equal to, greater than or equal to. Okay, and when we graph them, these two have open circles because they don't include that number. There's no equal to part. But since these ones have an equal to part, they're going to have a closed circle when we put them on the number line. Okay? Just like a recap. So to solve an inequality, we solve it just like an equation. And we're going to work on the side with the variable. Okay? And then we do have some special rules. When you multiply or divide by a negative, you're going to flip the direction of the sign. That's only when you multiply or divide by a negative, okay? I can show you kind of why that is when we get to it. Okay? So, solving an inequality, we start by solving it just like an equation. So I'm just going to start by rewriting the inequality up here. X plus 11 is greater than 8. And then I want to draw a line right here. Remember, like we draw it through the equal sign just to keep it organized. Then I undo what is furthest from the variable. This 11 plus 11, not very attached. So I'm going to do a minus 11. What I do on one side, have to do on the other. Okay. So then on the right, I'm just left with an x. Then 8 minus 11 is negative 3. You are allowed to use a calculator. Right? So 8 minus 11, negative 3. And then our symbol is going to stay the same. We didn't multiply or divide by any negatives, so we're good there. So after I solve my inequality, this is my answer. Okay? So I'm going to graph this one. It has a greater than symbol, so that's going to be an open circle. And we're going to start at negative 3. Okay. So I'm just going to plot those numbers. So I'm starting at negative 3 with an open circle. I need to choose some numbers to the left and the right. So negative 2, negative 1, 0, negative 4, negative 5. Okay. So then over on the side, I'm going to pick some points to the left and to the right of my starting point to see if it works. So let's choose negative 5. Is negative 5 greater than negative 3? No. So that's not going to work. What about 0? 0 is greater than negative 3. So I'm going to go towards this side of 0. And it's always good to do this step and just kind of check where you are and just double check. Even if you think you know it's going to go to the right, it's good to check some points as a solution. Okay? All right, this one, negative 8x is less than or equal to negative 72. I'm going to start by rewriting that and solving it. So negative 8x less than or equal to negative 72. Then I draw a line underneath my sign just to keep it organized. No mathematical reason, just for organization. Okay? I first undo anything that is furthest from the variable. There's nothing being added or subtracted here, so I don't need to do that step. Then I need to undo the coefficient. I'm going to undo negative 8 by dividing by negative 8. And anything divided by itself is 1, so we get 1x. Then negative 72 divided by negative 8 is positive 9. But since we divided by a negative, I need to flip the direction of my symbol. Okay? And let me get a piece of paper and show you why that is. Okay. So if I had left it as less than or equal to 9, and I chose, never mind. Just when it's a negative, you flip it. I don't have an example off the top of my head. Okay, so since it has an equal to part, it's going to be a closed circle. Okay, we're going to start at positive 9. So I'm going to graph those on the number line. So here's 9, 10, 11, 12, 8, 7, 6, 5. Okay. I'm going to pick some test points. We know we're starting on 9 and it's a closed circle, so we can go ahead and graph that. Okay, so let's pick 8 and we'll pick 12. So is 8 greater than or equal to 9? No. What about 9? What happens if we test 9? 9 is greater than or equal to 9. That is true. So that's why we color it in. And then 12 is greater than or equal to 9. So this side works, so we're going to color that in. So towards the side that makes it true. Okay. All right, this last example, 3 times a number is at least 21. So we have 3 times a number. We could do 3n, that's 3 times a number, is at least 21. So comparing it to 21. Well, 21 at least means that this is the smallest number it can be. So everything else has to be greater than it. But since it can be 21, it can also be equal to 21. So 3n is greater than or equal to 21. Okay? Then it's going to solve. I'm going to undo the 3n by dividing by 3. What I do on one side, I have to do on the other. 3n divided by 3 is 1n. And 21 divided by 3 is 7. I did not change the direction of my symbol because I divided by a positive. You only change it when you divide by a negative. Since it has an equal to component, it's going to be a closed circle. Okay. Our starting point is going to be 7. So let's go ahead and graph that. So on 7, it's a closed circle. Okay. Then I'm going to pick some test points. Let's choose 6 and 8. How about that? So is 6 greater than or equal to 7? Nope. Is 8 greater than or equal to 7? Yep. So this side works, so we're going to shade our arrow towards the side that works, which is to the right. And there you have it. Okay, so just like solving inequality, only flip the sign if you multiply or divide by a negative. Okay. So I'll do a couple of these with you. How about the ones from level 2? Okay, so you undo what is furthest away, not attached to the variable, which is a 6. So I'm going to subtract 6 from both sides. Okay, that leaves me p over -9 is less than -1. P divided by -9. To undo that, I'm going to multiply by -9. That leaves me with p. -1 times -9 is a +9. Since I multiplied by a negative, I have to flip my symbol. So p is greater than -9. And I'll let you graph it. Okay, and then I'll do this one from level 3. There's 15 students in a class. Molly, or how many cookies does Molly need to make so that everyone gets at least 3 cookies? Okay, so 15 students, everyone needs at least 3. Let's box at least. That is an important part of that. Okay, so this one seems a little backwards, right? So we're going to take the number of cookies. We don't know how many, so we're just going to use C. And we're distributing it to 15 students. So however many cookies there are divided by the number of students needs to be at least 3. 3 is the smallest number it can be, so everything else has to be greater than that. Or equal to, because we also have an option of getting just 3. Okay, so I'll let you solve that one. But we took the total number of cookies she needs to make, divided by how many students they're going to be distributed to, then everyone gets at least 3. So everything has to be greater than or equal to 3. Okay? All right. Go ahead, take your time, write them down. Don't try to rush through, but you got this. Good luck.